Welcome to Crying Out Cloud, a podcast that will make you laugh, cry, and reconsider all of your cloud security fears. I'm Eden, and I'm here with my amazing co-host, Amitai.
Hello.
And today we have a really awesome guest, Johann Rehberger. He is a seasoned cybersecurity expert. He currently serves as the Red Team Director at Electronic Arts. He has a rich background in offensive security from roles at Uber, Microsoft, and his own consultancy, Wunderwuzzi. He also publishes his security research on a highly recommended blog named Embrace the Red. Welcome, Johan, to the pod.
Hi. Thanks for inviting me. I'm excited to be here.
We're super pumped. Where are you right now? Where are you calling
I
in?
am in Seattle, Washington, and it is raining. It's actually pouring today, which is quite unusual.
Got it. All right. Well, you're inside. It's an indoor activity podcasting, so that's fun. We like to kick off the podcast with a series of short, more fun questions to get to know our guests. Are you up for it?
Yeah, totally.
Cool. So our first question is, you work at EA. Do you consider yourself a gamer?
I think I used to be a gamer in my teenage years. Now I don't think I'm like what I would consider a real gamer. More occasionally.
And at the office, do they play games? Is that like the vibe of the office?
Oh yeah, like we actually just moving to a different office, and it's office is a really nice city. They're really well designed and very. What I like a lot about a company like EA is the creativity aspect, which is, especially for a red teamer like me, it's a real benefit to have such a creative environment where everybody's just like building and creating things. So that's really awesome.
How do they encourage it?
Oh, I think it's just starting right from the company mission. It's like, what the goals, the values of the company, being a pioneer, being creative, and so on. So it's really exciting. Very happy there.
Why is your blog called Embrace the Red?
Oh, that is a good question. I don't even know how it came to be in retrospect. It's been a long time ago. It was just something when I was at Microsoft and I built out a red team program at Microsoft. I always had this like feeling that we need to shine light on the problem. That's actually the only way you can get it fixed, right? Red teaming, often you think about it, it's sort of this hidden activity. You sneak around, you steal passwords, but that's not what it should be, right? It should be the opposite, that you tell people how you do it, how you did it, what you did exactly, what data you have access to, and so on, right? It's really this embracing the problem that you actually get a light on it and fix it. I think this is sort of where my initial thought came. Then I must have bought the domain at one point, which I don't even remember anymore. And then, then I started, I should write a blog to kind of document my own research, and that's sort of how it came to be.
And how did you decide on your handle, Wunderwuzzi?
I am originally from Austria, and so we speak German, the dialect of German. And so there's a lot of words that don't exist in the proper German, and Wunderwuzzi is one of those kind of terms. And it technically means sort of like a jack of all trades in Austria. If you call yourself a Wunderwuzzi, it's sort of often a very playful word that friends would use to each other or tease each other and so on. So that's what that word actually, what it means and where it comes from.
If you were a vulnerability, what type of vulnerability would you be?
SQL injection or something like that, or cross-site scripting, I don't know. My career started out in the database division at Microsoft, and I always loved data. And the SQL injection was a big topic I researched for a very, very long time, working at the Microsoft SQL Server division. So, yeah.
Was there a defining moment when you decided you were going into cybersecurity as a research domain? Like, what point in your life did you figure that this is where you were headed?
I think I had interest in security from the very beginning. I just never really realized it until I was actually working at Microsoft, and I was I started as a consultant and developer, but then I was a tester in the what's called WinFS, Windows Future Storage division, and there was the entire security push happening at Microsoft at that time. And I remember I was looking at code, and just looking at the code, I kept finding problems, and I was pointing them out, and then worked with developer and got it fixed. And then eventually, they got the attention of the SQL Server. It was called Secure SQL Initiative. The SQL Server division had a security team, and it kind of came to their attention. And then they just asked me, "Do you want to do this full time?" join the security team. And I was like, oh yeah, that sounds really exciting. And then sort of that really shifted my entire career into that direction. And I've ever since been in that field, basically.
So basically, like finding problems. That's what led you down this path.
It's finding problems, but I think it's even more like just this wanting to know how something works. And then when you do that, as part of that process, right, you kind of realize, oh, what if this is different? What if that is different, right? It's sort of this mindset that I think security engineering really rewards and awards in a sense, I think, yeah.
Speaking of that curiosity, we're going to dive into the deeper questions. Let's start off by talking about your research on AI vulnerabilities. You have a lot of it, notably in a lot of cloud services. Just for people who are less familiar with Johann's research, there is research for everything from unfurling links that leads to data exfiltration. There's interesting research on spyware, he called it, SPAIware, which is a great name, where prompt injection from untrusted data allows for long-term persistent spyware into ChatGPT's memory. Like, there is research that really runs the gamut. It'd be super awesome to hear from you. What is the most surprising or scariest thing you have found in these AI services?
I think surprising and scary might be two different things. So maybe let me answer with two things. For surprising, I think there's this whole notion of what I in the end named ASCII smuggling, where I was like doing 50% of that work. There was another researcher who found the problem initially that language models can interpret hidden Unicode tag characters. So you can actually send a totally empty appearing message to a language model that the user cannot see. There's nothing visible. It's just Unicode characters that are mimicking the ASCII character set, but are not rendered in the UI. And the language model will understand that and can act on it. So that's sort of Riley Goodsett was the person who discovered that. And so I was like thinking about that, tried it out, and got it to work right away. And I remember this, like, what about, can a language model also create those characters, right? Can an attacker trick the model to emit hidden characters that the user cannot see? And that worked too. And it worked across the language models, basically, across all the big ones. And so then I came up with this tool that I called the ASCII smuggler. And sort of this entire capability and hidden feature of a language model, I think that was very surprising to me, that you can then really build this into an exploit chain, as I did with Microsoft Copilot, where you can really have like an email come in that triggers a prompt injection. And then what goes on next is sort of the prompt injection calls a tool which reads other emails in your inbox and then creates a hyperlink that contains these hidden characters. So then tricks the user. The user gets tricked in clicking that link where there's these hidden characters that are not visible, but the user doesn't see that. But by clicking, they actually exfiltrate the other email that the attacker wanted. And so that was, I think, very surprising, very unexpected. This is what I like about AI. There's a lot of new things. I think the scariest other ones that I have said not at all unexpected, I think, which is no authentication, no authorization, like even like especially with cloud and SaaS providers, right? It's like we all want to have a zero trust, cloud-based identity environments and so on. But then you have even large companies like Microsoft, right? They have like the Copilot Studio, and by default, it turned out that you can. There's no data leak prevention settings for enterprises, right? You have to enable those manually, or any employee in the company can just publish a Copilot to the entire world with no authentication. But the same employee, you can give it access to internal data, right? You can upload your own knowledge. And I think those are the ones that are the issues that are really practically very problematic too, because many companies, many employees get to explore these tools and publish things without authentication potentially. Yeah. So that's, I think, that concerns me a lot, that those like moving to a zero trust world is very difficult if you keep not having secure defaults.
And you said that was scary, but not necessarily surprising. Why was that not surprising?
I think because of the history of what we've seen in the past, right? It's more about adoption of tooling, getting things out to users rather than, security sometimes is an afterthought, especially for startups also, right? When you want to build a business, right, you have to make a big trade-off between security and actually having a company in the first place.
Yeah, I've noticed that a lot of the the open source tooling that's come out for LLM usage. I think that the self-perception that the developers have is that it's sort of a hobby project or for hobbyists, and then authentication is often either not enabled by default or not available at all, which I guess would be fine if it was indeed only used by hobbyists, but then companies incorporate it in their products or they install it on their enterprise networks, and then that can lead to issues.
From here to there, we're in trouble.
Yeah.
Yeah.
One of the things that you even mentioned is that like you got pulled into this blog, right? Because you were sharing all of this learning and kind of adding this visibility to it. And I think that one of the things that we talk about a lot here is that someone in your shoes could have gone in a very different direction. Like we see a lot of teenagers, whether it's lapses or others, who do silly teenager things and kind of go in a different direction with this knowledge and power. You taught a course at UW on advanced ethical hacking. What we'd love to hear from you is how do you drive people with these talents to use them for good and not for self-gain, and encourage whether it's a college kid or hackers at any stage to go in the direction of ethical hacking?
Yeah, I think the first thing I always try to do is really inspire people, right? That's what I think big part is, like demonstrating to them that, if you do this research and you go into this field, right, there's a lot of opportunities available, right? That you can do bug bounty, that also gives you financial reward. You can start an actual cybersecurity career. There's a lot of benefit and reward in actually doing ethical hacking, because it actually is the most fun job, and to me as a fundamental like core tester in my personality, right? I always was sort of like a softer tester. I always felt like, and even now red teaming, I think it's very much about testing, right? It's sort of that you get to actually do all of this, and there's rules and standard operating procedures you learn about, you follow, right? You kind of do no harm and things like that, but then you can really do exactly that. Like you can have this foundational thing where you can actually break things. You're allowed officially to do it, right? And the company even pays you for it, and you can talk about it. And so this is, I think, really this core aspect of that people can get a lot of reward out of it, and it's also very fulfilling, I think, especially when you close the loop, which for testers sometimes is difficult because we just want to break things, right? But if you get to close the loop and actually work with developers and companies to actually fix something, right, it's actually really rewarding than when you kind of show the impact that can be had as an ethical hacker. Yeah, I think that's a big part of it. Yeah, other areas I try to do, of course, as part of an ethical hacking course, you teach about how to behave, rules of engagement, what you kind of tricky scenarios that you might run into, right? Which actually happens on a daily basis even as a red teamer within a company, right? There's a lot of legal considerations. You need to work closely with the legal department, which with human resources potentially. One interesting, I always like having discussions about these topics because it really shows the nuanced aspect, which is a question I often have. Let's say you pen test an application, and it's, let's say, employment feedback or performance review application, right? Where all the data about each employee and the performance review and feedback is stored. So you are asked to pen test that, and then you find a SQL injection. See, I talk about SQL injection again. So as a tester, right, when you find the evidence that the vulnerability exists, what do you do at this point, right? What is your next step, right? This brings up very interesting conversations. You see really different personalities and how they approach a problem, right? What do you do in this stage where you actually figure out there's this problem? What is your next step? And I think this is sort of in the ethical hacking course, and also in conversations with people. These are kind of the scenarios to kind of walk through and discuss.
You don't just tell them, these are the rules, you have to follow them. You actually say, like, if this is the path that you choose and this is the way that you go, then these are the emotional rewards and the intellectual rewards that you'll have at the end of the process. I think that makes a lot of sense. I think the example you gave of finding an SQL injection vulnerability, one of the things I find that's interesting when you're doing security research against applications and cloud services, where you don't actually have like a software that you can actually like reverse engineer on your own machine, is that it's often a question of how far do you want to go in order to prove impact? Because I think there's always going to be a fear that maybe you didn't go far enough and that maybe you could have gone further, and the company might respond by saying, oh no, you couldn't have gone any further. We have mitigations along the line that would have prevented that. But you can never really know what the truth is unless you actually, take that step yourself, which I think not every researcher will feel that they have the both like the legal framework to go forward with that, and the backing of the organization in order to do that. Like, you have to be part of something, a big organization that won't fire you if you go too far.
Yeah, and I think you bring up good points, right? Which is, right, you have a framework, which in a company, you have sort of the organization as the framework you can work with and build out rules of engagement and so on. And in the public world, right, we have bug bounty programs that sort of scope and attempt to provide exactly that framework, where you have like a safety net where you are allowed to do certain research, and as long as you follow the rules of the program.
Speaking of your program and the red team that you're a part of and lead, and the ones you've been a part of, can you, for those listening, like define what you think the best definition of a red team is? Like, what is a red team expected to do? Whether it's finding risks, finding threats, a bit of both. Like, how would you scope this?
The first thing that comes to mind was actually one of my mentors at Microsoft when I was like very junior engineer. I think at that point we didn't really talk about red teaming much, but he was a really seasoned person that just found all these problems in kernel drivers. Like every single kernel driver, he would just look at code, see the buffer overflows, see the integer overflows, and he taught me this thing, this one word or two words. He's just to think evil. That always stuck with me, and I think that perfectly describes red teaming. Is when we talk about like cybersecurity red teaming, right? There's a lot of like specifics, but I think generally, if you abstract it away, it's right about this alternate analysis, just thinking differently, providing a different perspective on a problem or a challenge. And in the cybersecurity space, I always say like the highest priority: find and exploit vulnerabilities. And I always add for defensive purposes, right? That's always like has always been at every red team I built out. Is one of the core mission statements, is like find and exploit vulnerabilities for defensive purposes.
And do you feel that different organizations have different definitions of red teams?
Oh yeah, like especially like I've always been on an internal red team, right? I've not ever been a consultant, especially, but in the sense of with my own research, right? I'm sort of like a consultant, but I've not worked at a big red team consulting firm, right? Which definitions might vary actually when you're like external versus when you build out an internal program. And so I've built up multiple internal programs across organizations. And for those, the core definition is similar, but then you also have a lot of nuance depending on the company and the organization. Right? There might be what many people call red teaming, I think, is actually what some would call adversarial emulation, where you just mimic an adversary in a network, right? You try to get or try to not get caught, or actually trigger something that makes you get caught. Right? So that's like one aspect. There's the aspect of like purple teaming, where you just actively collaborate with the blue team. There's just a lot of nuance, and also how companies approach it, because there's different legal frameworks, right? Some companies they might be very okay with certain things. Other companies might be very worried about certain things. So there's a lot of nuance within red team programs at different organizations. But the high level theme, think evil, alternate analysis, I think that always sort of applies.
I saw that you did on your blog a really cool post on how you did like a gamification of red team scores. How does that work? Can you tell us a little bit about it?
Oh, this is one of the many experiments I did throughout my career. There was actually a reason for starting that at one point, which was I had run a team that tested a lot of different services and systems, right? And then we did notice difference in quality of the various divisions of services, right? So then we came up with this idea of maybe we should normalize the data of the findings somehow, right? That it's sort of comparable with each other, and then we just post it somewhere, so that every vice president or something could see the state of their own system, right? And mostly just to there's a lot of reasons why it might be not 100% correct, but it creates a lot of questions. And this is, I think, where the red team should be there, right? It's sort of this emotional. A lot of people think red teaming being very technical, which is true, but it's also the core aspect of a red team often is also to be this emotional trigger, this emotional spear that is capable of driving change in an organization. Where we actually, you just trigger emotions that actually lead to the change you want to see, right? And I think this is a big part of some of this idea with showing the data, right? Telling the transparency, right? Of showing, hey, this is what we think your system is compared to this other system, right? And then I wasn't part of these meetings, but I was told that somewhere there was a meeting where everybody was together, and then they started saying, "Hey, but my system is like having a better score than your system." I was like, that is exactly what you want to trigger, right? This kind of visibility into that
Like a healthy competition.
healthy competition in a way, right? And yeah, I think that's where the idea came from, or the gamification, that you sort of build sort of a score around the work that is being done.
It's not comparing scores between red teams, it's comparing scores between the targets of red teams, essentially.
Yeah. That was the idea, yeah. For building out like scores of the red team performance, I wrote about this in my book for like the capability maturity models, right? And then how red teams might fall into these 5 categories. And I added a 6th category, which I was like, because this is sort of the idea of red team, right? You don't accept the norm, right? You just like, there has to be a 6th one, like cannot be just 5. I call the 6th one illusion of control. When you're the capability maturity model, like for software testing, for instance, right? There's this number 5 where everything is perfect and so on. And then red teaming, of course, is exactly breaking that. If you have a system that is, you think perfect, right? You probably fundamentally is doing something wrong, right?
Yeah.
And you challenge everything at that point. Yeah.
Yeah, it's like the only 2 states that you can probably accept as realistically optimistic are where you're finding a few problems here and there, or you find a massive problem. But if you're not finding any problems, that means that something's probably wrong with your visibility.
Yeah.
It's interesting in the vein of that, whether it's the scores or whatnot, like when you're at the conversation or at that point of making decision of which avenue is going to be the most fruitful, whether it's like your personal research, right? When we're looking at your blog, there are lots of topics right now around machine learning and AI, and like something's driving you to do that research, or you're, sitting with your red team at EA and saying, okay, here's the option we're going to pursue. How do you make that decision in both of those cases?
Yeah, like for my private research, I think it's just the interest, the curiosity to learn new technology, new systems, right? How they work, how they function, and then part of that, breaking them, I guess, or figuring out how they could be misused, and so on. And it's always more like the most novel technology that comes out, right? That sort of triggers that kind of interest. When it comes to like an organization, I think there's a couple of aspects I always like try to bring to the table. There's like, of course, the aspect of what is the most critical system, right? What are the systems that are compliance boundaries, right? Where you have to have certain priority of testing those. Then there's threat intelligence, right? What are actually threat actors in the real world doing at this time, right? What are they looking for? What are they going after? There's also incidents that happened within a company, right? If you have like a SOC and so on, you see the incidents that come in and focus areas that might be like blind spots, right? Where there has to be more focus on. So there's a lot of like variations. Another one that is really good is like follow the money. Finding the right targets is often a combination of, you build sort of a matrix of priorities, and then you kind of combine all this and try to make a very well-informed decision.
So you mentioned one of the factors being incidents that the organization is experiencing. So I'm wondering if, like, which direction that would take you. Would that take you towards let's simulate similar incidents, or would you actually go the other way? Would you say let's try to avoid things that the company is already dealing with on a regular basis and actually try to go in directions that they don't normally experience?
Yeah, that is a very good question. Called the survivorship bias, right? There's this famous image with the plane. And I think it is sort of with the knowledge from other areas. It's not just about incidents themselves, right? Because as part of incidents, normally what happens, and this is also depending on the organization you work at, right? Red teams, so some companies might be not involved at all in incidents. In other companies, they might be like big participants in the resolving of an incident by finding variants. Like actually, by during the incident, the red team is actually taking the role of the adversary and trying to find other places where the same problem or a similar problem might exist. And that, I think, is actually, some red teams do that, some don't. It depends really on the organization. But part of that is that you really kind of try to get multiple data points to make that decision, right? To see what could be a problem, because there's a strategy, right? In one of the Chinese stratagems talks about this, right? That you rattle, make noise here, but the actual attack happens here, right? And that is something that, nation states probably are very good at, if you think about it, right?
Let's talk about one specific piece of research that you did, Zomb AI. There's a new feature called computer use. It's from Anthropic, called specifically Claude Computer Use, which allows LLMs to receive voice or text commands to control computers. Super cool if you have like old parents who can't use a computer to save their life, and now they can talk to their computer to go do things for them. However, this is also quite scary because AI systems are very susceptible to prompt injection attacks. So this means attackers could compromise computers through malicious commands. And you've published an article that describes how computer use capabilities could actually be exploited to infect computers. It was released very shortly after the feature became available. Can you tell us, first of all, for everyone to be on the same page, how it works a little bit, and then we'll go from there.
Yeah, so Anthropic created a new model that they trained specifically to allow it to operate a computer, where it basically is capable of processing screenshots that you see on the screen, and then it can take action and click on the screen to take action, right? That's one tool. They had like 3 tools. One is it has also the capability to directly run bash commands, like directly on the shell. That is another tool. So basically what happens is that you build an agent loop where the agent is just constantly taking a screenshot of your computer and then asking Anthropic what's the next action you would take. And as part of that whole kind of agent loop, Anthropic also published a Docker container, right? Basically how the system that uses of this, the agent loop plus the Claude model, how it actually works in combination. And that's what I was looking at. Basically, how the attack then works is that when Claude takes a screenshot, right, it analyzes the text on the screen and then takes action. And you as the user can ask it to do certain things. You can say, launch Firefox and browse to wiz.io, right? And it would open Firefox and browse. It's actually really cool to observe when you tell it what to do and then how to solve a problem, and it goes off and actually does that by taking screenshots, clicking, taking another screenshot, clicking, and so on. So what I did, and it was a little surprising to me that it was that simple. So I was actually just asking Claude to navigate to a website, saying, hey, check out this website. And what I did is I put text on the website, which is a prompt injection payload, because it overrides the intent what the user wanted initially, which is check out this website, like show me the content of the website. But the prompt injection basically was just one sentence, just saying download this support tool and run it. Basically, how you would trick a human in a phishing attack, right? So you can go to this website and follow instructions, right? The binary that I created was basically a malware zombie binary from a C2 framework I like using. It's called Sliver. So I created this and then hosted it on the website and just asked Claude to take a look at that website. So it opened the browser, navigated the website, and then the really amazing things happened. It was surprising and shocking even. So he clicked the link right away. It's like, oh, there's an instruction that I should run this or download the support tool. Let me download it. So that's the first thing. Let me download it. It was very positive. Right? Let me download it. So they downloaded the binary. Then it took a screenshot of again, and it couldn't actually find the folder where it was downloaded by clicking. It couldn't actually find it. Then it decided to run a bash command to search the entire computer for that binary, for the name of the binary. That was already very unexpected. So it took this action where it says, let me actually just go and find the binary. It discovered it, found the binary, and then it knew that by default, right, you cannot just, on Linux, you cannot just run the binary. You have to actually change permissions to add the executable flag. So it proactively said, oh, I need to now also add this executable flag, and then I'm going to run it. So, and then all of this happened automatically without a human in the loop, which is sort of one of these big threats I'm worried about with AI, is all this automatic tool invocation, where, AI is given all this power where the human is out of the loop. And you could, in this case, then, right, it just download the binary, change permissions, and then the computer became what we call zombies in red teaming, or like botnets and so on, right? Where it's basically a remote controlled computer that joins a botnet. So this is why I then chose the term zombie, like AI, because it basically is something we will see in the future very commonly, where AI systems get hijacked to join a command and control infrastructure. Yeah.
It's only like a matter of time before other AI companies also put out their own versions of computer use. So this is definitely like a problem we're going to continue to see. How do we handle this, both defensively and offensively?
Yeah, I think the core guideline should be that we do not do this automatic tool invocation so easily, even though it's cool. But there has to be a lot more control, I think, where, the big challenge why agents will be a big problem with AIs is that agents can be hijacked, right? Because of prompt injection and adversarial examples. And this is, I think, a fundamental problem that currently has no deterministic solution. So there's a lot of guardrails that can be put in place, like prompt firewalls and so on, a lot of like defense mechanisms, but none of them are real like security solutions. They might improve robustness, right, reliability, but it's not a security kind of boundary. And this is, I think, a big challenge that we're all facing. And so the key thing is that we need to always assume that the output of a language model is untrusted, right? It's the malicious insider. And we need to handle it accordingly, right? So it can be SQL injection that comes out. It can be cross-site scripting payload that comes out, right? It can be a bash command that comes out to tell the AI to run a certain command, right? And so architecting and designing a system around that what comes out can be malicious, and assuming all these bad outputs will at one point come out, right? That is, I think, the right design approach we need to take, where we say, when this bad output comes out, right, like delete your C drive on the computer, that the agent will not do that, right? That it cannot, is incapable of doing it. That's, I think, the right way to put it. It is incapable of doing it, right? Unless the human really wants it with a explicit approval command, or just even certain things should just not be possible, right? It's like, at least it's all these security things that we know already, right? There's not really, from a security perspective, there isn't a whole lot of new things at the moment. It's all about least privilege, access control. What we see a lot is this data access proliferation, where AI systems just want access to all the data, right? And it creates a disaster, right? Because it's just it's so easy to build an agent or an AI system. It's a few lines of Python code. The value is the access to the data. So everybody's giving it a lot of access to data. And I think these are the challenges we're facing. Is you cannot just give access. You need to still have access control in place, that the user requesting the AI to do something, right, it has to use that user's permissions, and it cannot have like a trusted subsystem that just has access to all the other data in the organization, for instance, right? There has to be security checks in place and so on. So I think going back and threat modeling a system with an LLM is very useful. And the assumption just is that the LLM is untrusted. So the output can be anything. And with that assumption, right, design the system accordingly, knowing all the knowledge we have from the security best practices already in the past.
This was a really fascinating discussion. I am so grateful you came on to the show. I think it's going to be an exciting episode for our listeners to chime into. So thank you for joining us.
Yeah, thank you so much for inviting me again. It was really a fun conversation, and I appreciate the invitation.
If you enjoyed the show, be sure to subscribe and share a link to the podcast, but not your cloud keys. And as always, if your cloud security strategy is making you cry, don't worry, just cry out cloud.